Hello viewers, I am Dr. V. Venkatramanan, Faculty, School of Interdisciplinary and Transdisciplinary Studies, Indira Gandhi National Open University. Today, we will be discussing about the climate change. In fact, I will be introducing the topic of climate change to you. We all know Earth's climate has never been static. It was always changing. And the present day, if you look at it, it is changing very fast, and certain unique features are there in the present day changing climatic conditions. The foremost important thing is the present day climate change. We call it as modern climate change. Why? Because this modern climate change is because of human actions, because of anthropogenic activities, because of the way we use the fossil fuels. We are consuming a lot of fossil fuels, and that is causing a lot of harm to the environment, particularly changing climate. And that is the reason why the present day climate change is called as anthropogenically induced climate change. The second important factor of visible changes that you can find it in the present day climate change is the rapidity, the quickness, the kind of impact. It is so pervasive, and you can find the impact of climate change in all the ecosystems, and in fact biospheric system itself is going to be affected because of climate change. And simultaneously, if you look at it, the impact is so huge, and a lot of measures, a lot of mitigation and adaptation measures is required to contain the changing climate, and if not, it may lead to civilizational collapse also, because every aspect of a human being that is impacted by climate change, not only that thing, the ecosystem or the other living organisms also affected by climate change. And that is the reason why we are saying that we are in the era of sixth mass extinction, and one of the important factor for causing loss of biodiversity is climate change. So with this short perspective in our mind, let us see what exactly climate change is. And we know that in the past century, in the last century, if you see it, a lot of changes, visible changes we have seen in the climate change. The first and foremost important thing, you can see that human beings have caused a lot of changes in the atmospheric system, and perhaps that has led to a lot of change in the temperature, and all kind of interaction that is taking place in the climate system has been impacted by human activities, particularly use of fossil fuels. And in other words, the industrial activity and kindred related issues like urbanization and land use changes, agricultural activity indeed. So all have caused a lot of changes to the climate system. It is it is changing so fast that is resulting in change in average air temperature. So the human activities, the report says that, in IPCC report states that human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial levels. And it's a remarkable change that if you see it, because 1 degree centigrade is already, it can cause a lot of changes, visible changes to all possible ecosystems on the earth. So definitely there are a lot of measures has to be taken. And more importantly, if you are not taking right steps at right time, whether it's a policy decisions or pragmatic solutions, sustainable solutions, if not, the temperature increase will be much further, and it may reach to 1.5 degrees centigrade, not far off. Between 2030 and 2052 itself, the temperature can increase, the surface air temperature can increase to 1.5 degrees centigrade. So it is a cause of concern. The second important changes that you can see for yourself since Industrial Revolution is, yes, the changing concentration of greenhouse gases in the atmosphere. The foremost important gas is the carbon dioxide. Before the Industrial Revolution, it was 280 parts per million, but now it has crossed 410 parts per million. And the kind of pumping, human action is pumping a lot of greenhouse gases into the atmospheric system, and that is causing a lot of harm to the environment. Particularly the changes that we are finding in the global level, the global changes, that's also responsible, that is also cause of concern, and it is because of Industrial Revolution. when you see the carbon dioxide concentration, increase in the carbon dioxide concentration since industrial revolution, a major part has been absorbed by the ocean body. And because of the absorption of carbon dioxide by the ocean body, the acidity value, the pH value of ocean body has reduced, and the effects, consequences are many because of ocean acidification. Think about what kind of impact it can have on the living organisms that are living in the water body, ocean body, the fishes, the corals. There are so many organisms are there in the ocean system, marine ecosystem, and that is deeply impacted by ocean acidification. And that ocean acidification is because of increasing carbon dioxide concentration in the atmosphere, and a major part of atmospheric carbon dioxide has been absorbed by the ocean body. And the value, if you see it, since industrial revolution, the pH of the marine body, ocean body, has reduced by 0.1 pH value. It has reduced. So that is another cause of concern, because the ocean body is actually, basically, if you look at it, it is ocean itself is like lungs of the biosphere, because all possible the biogeochemical cycling of nutrients and the energy and everything is influenced by the ocean body. In fact, if you look at it, the 90% of the increase in the the energy that has been absorbed by the ocean body. Look at the kind of the homeostasis. Look at the kind of the buffering capacity of the ocean body, and that is the most important thing we need to understand at this juncture. The third important thing, because of climate change, you can see whether it is an Arctic environment or the Antarctic environment, the glacier masses are melting, and you can find a lot of sea ices. It's all because of climate change. The glaciers, whether it is in the Antarctic environment or even in the mountain glaciers, I mean the continental glaciers, that also are deeply impacted by climate change. And the fourth important thing, as far as the symptoms are concerned, yes, I repeatedly saying that the living organisms, many of the organisms, because they cannot switch over the kind of climatic conditions, they are suitable to certain niche areas, and because of the change in climatic condition, they are also impacted. Their livelihood is impacted. Yes, for instance, human beings, think about the livelihood of the human beings, they are impacted. And think about the sectors like agriculture, which is totally dependent on climatic conditions, and that those sectors, those enterprises also impacted because of climate change. That we can see for ourselves. And very interesting point is that the livelihood of the people living in the island ecosystem, yes, Pacific Island dwellers, and their life is at stake. They are threatened because of climate change, because of the increase in the sea level. Any time they can be drowned. In other words, if you look at the past century, almost 0.19 meters in the sea level has rose, and this particular increase in the sea level definitely is causing a lot of harm to the Pacific Island dwellers, or for that matter island ecosystem it is affecting. These are all the visible changes that we have seen in the last century, and it has been recorded, and it's now clear. We can state that the climate system is changing, and the climate system is deeply impacted by human actions. Okay, and to proceed further in our discussion, let us understand the basic, the conceptual difference between the concepts like weather and climate. It may sound simple, yes, it is simpler concept, but nevertheless it is important because when we need to understand much more the interaction that is taking place in the climate system, we need to understand the basic difference between weather and climate. And both sound similar, nevertheless certain minor differences are there between the terms weather and climate. And as far as the differences are concerned with weather and climate, is the space component and the time component, or in other words the dimensions. To define weather comprises the day-to-day conditions of the atmosphere at any place. It is never static and thus cannot be generalized. In other words, Weather, the concept of weather, when we speak about weather, we are talking about a smaller area at a small place and for a smaller period of time. On the other hand, when we wanted to discuss about the climate, it is for the larger area, for a larger area and for a longer period of time. So that is the basic difference between weather and climate. To define climate, yes, it is the average state of the atmosphere. That means that the weather patterns over a larger area. So when you talk about a climate, we will be talking normally about the weather records of a minimum period of 35 years, to understand the climate of a particular region. So we will be taking we will be understanding the weather parameters, whether it is a temperature, precipitation and other meteorological parameters will be taken into account to understand, to study the climate of a particular region. So these are the basic difference between weather and climate. And as far as the concept, whatever we are talking about, everything is happening in a system, and that is called climate system. And when you talk about climate system, it has been defined by the United Nations body. The United Nations Framework Convention on Climate Change defines the climate system as the totality. It's a comprehensive term. It's a totality of the atmosphere, hydrosphere, biosphere, geosphere and their interactions. It's basically these kind of, all the systems. It's a climate system, it's a very comprehensive system. Within that, a lot of subsystems are there, whether it can be an atmosphere, it can be a hydrosphere. Each and every system starts interacting with each other, and that is the reason why we need to understand, if we wanted to understand more about the climate and the climate dynamics or climate change and the variability, we need to understand the components of climate system at the very outset. And not only the components, the kind of interaction that is taking place, the feedbacks and the forward and backward linkages with the systems, subsystems I mean. So every system, subcomponents of the climate system operates in dynamic in nature. That is the reason why the climate system, it is changing. It's dynamic in nature. Nevertheless, that dynamism is very important for us to look at the things that is happening, whether it's the weather phenomenon, the cyclone, and everything is because of the interaction that is taking place in the climate system. And particularly human beings, think about how their actions, the economic activities or any other activities for that matter, they also can cause a lot of harm, or in other words, they can change the system dynamics. They can bring in a lot of complexities. They can perturb the climate system, and that is the heart of our discussion today. That is climate change. And in front of you, wonderful picture where you can find for yourself that we are talking about the climate system, whether it's in high atmosphere, how it is, and the kind of interactions you can see for yourself now. And when the important point here is that the climate system is driven by the solar system, the energy, solar energy, that is the driving force of the climate system. And we'll be discussing in detail about the climate system in the next session, the kind of interaction that is taking place and how that interactions are important for us to understand the changing climate, and also how important for us to prioritize in our action, climate action. When I say climate action, we need to focus on the mitigation strategies, we need to focus on the adaptation strategies, and in order to prioritize the best possible strategies, or in other words, a sustainable approach is required in our approach to contain the climate change. And for that reason, the basic understanding about climate system is essential. So basically we can understand about the global heat budget, and it is there, we can see for yourself that how global heat budget is, it is dynamic in nature, and this global heat budget has been influenced by the change. Many factors are there. It can be natural reasons, it can be the human induced reasons also. And in other words, you can say that the changing climate is because of either because of the natural causes or anthropogenically induced causes. And we must understand that the present day climate change, the most of the impacts what we are seeing is because of human action, and that is the reason why I stated clearly that the present day climate change is anthropogenically induced climate change. Well, we need to understand the term climate change as such, because we have discussed about the terms weather and climate, and we need to understand climate change. And from the definition, the good definition has been given by the world international bodies, the United Nations or the WMO, World Meteorological Organizations. Let us see the definition. The climate change, what it means is that it is a change in the state of the climate that can be identified by the changes in the mean and or the variability of its properties, and that persists for an extended period of time. Typically for a longer period of time, it can be decades as well. So this is a basic definition has been given by the United Nations body. And on the other hand, when we discuss about climate change, there is another terminology is there, that's variability, because any meteorological parameter, if you look at it, there are two concepts. One is the mean and the other one is the variability. When you talk about the climate variability, for instance, it is about the variations in the mean state and other statistics of the climate, on all the spatial and temporal scales beyond that of individual weather events. So it is about the variation. It's about the variation. So I'll be happy to explain to you with a picture. In front of you, we have a graphical presentation of a meteorological parameter. Take for instance any time series data. Well, if it is a stationary data of any meteorological parameter, it can be a temperature, it can be precipitation, or it can be any other meteorological parameter. See, if it is a if you see it is a stationary data, if it is a time series data is stationary, it means that for a smaller period of time, you will not be finding any kind of variations, for a smaller period of time. On the other hand, there can be variation between the observations. That does not matter, but as far as the time series is concerned, for a shorter period of time you will not be finding any variation. So having said that thing, you take for instance a temperature as a meteorological parameter and you place it, represent it in a form of a graph, you will be finding that statistical parameters can be represented by a bell-shaped curve that is there in front of you, bell-shaped curve, and there it can be any parameter. Yes, we are discussing about the temperature. Temperature, you can find the bell-shaped curve. And for instance, when you look at the bell-shaped curve, it's a normal distribution. Yes, the peak of the curve, that is bell-shaped curve, signifies the mean value, and the limb of the curve is the variance, variability, variance. Okay, these are all the two important statistical parameters that you can easily gauge from this particular bell-shaped curve. So when this bell-shaped curve shifts towards the right side, it means that the mean value is changing, it is increasing. That means that the climate is changing. In terms of the mean value, it is increasing. So in that case, what happens, what kind of consequences you can find is that you will be finding the hot weather, the frequency of hot weather, hot days, that will be increasing. On the other hand, you will be finding the frequency of the cold weather to decrease. So if that is the case, you can say that the mean value, the mean value is shifting towards a positive side. In other words, it is increasing. Okay, mean value is increasing. See, on the other hand, if you see the bell-shaped curve, if it is flattening, what it signifies? It signifies that the variability is increasing. You will be finding more of hot weather conditions, more of cold weather conditions. So the variations, you will be finding more of extremities. You will be finding more of extreme events, extreme weather events. So this is about the climate variability. So there is an increase in the variance. So that is the most important point. One aspect is the increase in temperature or increase in meteorological parameters. The other one is the variation. So if both are simultaneously happening, in reality it is happening simultaneously. So there is mean value is also increasing. At the same time, the variation is also increasing. So in that case, you will be finding more of hot weather conditions. And that is what present day you can see for yourself that it is happening. That is, the climate change has to be taken along with the variability concept also, because the variability, whenever we talk about change and variability, what it signifies, most importantly, the predictability is difficult. It's becoming more of unpredictable. Extreme events is very difficult to predict, and at the same time impacts are more dangerous. And it's a lot of, you can see for yourself the kind of the urban floods, you can see for yourself the extreme weather events that is taking place in our country. Elsewhere you can see the extreme weather events, the impact is much more in the present day conditions. So this is all because of climate change. So climate change has to be taken along with the variability also to study in a comprehensive manner. So having said the basic concept about the climate change and variability, let us look at the drivers of climate change. I said that the climate change can happen because of the natural causes and also human induced causes also. Nevertheless, the present day is because of anthropogenic reasons. But before the Industrial Revolution, whatever the changes has taken place, because Earth's climate has never been static, it has been changing, and it moves towards the equilibrium. It tries to move towards the equilibrium. So in that context, if you see, a lot of natural causes also there to cause climate change. The most important thing is the driving force of the climate system is the sun's energy. There is the solar output itself can be variable in nature. Understood. And that is also an important factor has to be taken to account, because the kind of the solar output, what is the dynamism, what happened since the Earth has about 4.6 billion years from that particular point till now. So the variability that is in the solar variability, that also has caused climate change. Okay. And the second important point is the Earth's orbit around the sun, and this is also a cause of, important cause, because very interesting point here is that the ice ages in the past, lot of changes as whether it is the ice ages or the lot of cold environments in the past, past, I am talking about the past millennia. It's all because of very important reason is the orbital variation, and it is called as Milankovitch oscillations, the oscillation that is taking Earth's oscillation around the sun. And if you see, very important thing is it's called the Earth revolves around the sun. The orbit can be either elliptical, or on the other extreme it can be circular. And this particular period, the Earth's orbit around the sun, oscillates between the elliptical thing or circular, and this particular period, if you see, it is associated with 1 lakh, 1 lakh years, and this we called as eccentricity. It is very much part of a Milankovitch oscillation. The second important thing is the obliquity, the Earth's tilt angle. It's Earth's tilt angle, that is, it can also oscillate between 21.5 to 24.5, and this is also this particular Earth's tilt angle. This is called obliquity. It is associated with a period of 41,000 years. And the last one is the wobbling effect. We call it as precession or a wobbling effect. This is also associated with around a period of 21,000 years. So this is basically called Milankovitch oscillations and orbital variation. This can also cause climate change. And a very simple thing, the sunspot cycle, we have known about the sunspot cycle. The changes that is happening during the sunspot cycle, that also can reduce or increase the solar activity. That's the solar activity, sunspot cycle, and that amounts to the solar output varies about 0.1%, but nevertheless 0.1% of solar output also can increase the temperature, Earth's surface temperature, to 0.2 degrees centigrade. So sunspot cycle is also important, equally important as far as the natural drivers of climate change is concerned. And this other causes are tectonic processes, a lot of processes that is taking place in the landforms, so that also can cause the climate change. And the last one is the volcanic eruption. We can see for when the recent past in 1993, Mount Pinatubo released a lot of gases, a lot of aerosol particles into the atmosphere, and that has changed the solar radiation reaching the Earth's surface. And perhaps these 4 important reasons, solar variability, orbital variation, tectonic processes, sunspot cycle, volcanic eruption, these all are under the they also cause climate change naturally. Okay. Now let us go to the anthropogenic reasons. Anthropogenic reasons. When you talk about human beings, and the most important thing is we can see for ourselves the industrial revolution, the use of fossil fuels. And when you talk about the use of fossil fuels, the economic activity is totally dependent on use of fossil fuels, energy consumption. And because of this industrial activity, economic activity, human activity for that matter, so a lot of greenhouse gases have been pumped into the atmosphere, and that the changing atmospheric concentration of greenhouse gases is definitely, you can see for ourselves that how the atmospheric composition has changed since industrial revolution. We will discuss in a few minutes from now. The atmospheric composition is the most important example. You can take it for definitely for explaining the anthropogenic reasons. The second important thing is the land use changes. Since industrial revolution, along with the increase in the population, a lot of demand for food, a lot of demand for the land area for any whether it's an urban activity or agricultural activity also, it's a very important thing. So because of the land use changes also, greenhouse gases has been emitted. For instance, agricultural activity and related land use practices are responsible for 1/3 of anthropogenically emitted greenhouse gases. So the land use changes also a second important cause for climate change. The third important thing is, it's a related one, the aerosol concentration of the atmosphere, and it's also because of human actions. Okay, and this particular graph, it's interesting graph. You can see that how the concentration of carbon dioxide is increased since industrial revolution. The carbon dioxide, methane, and nitrous oxide. Now, carbon dioxide, as I said, it has touched 410 parts per million. In fact, it has crossed 410 parts per million. And as far as the methane is concerned, it has crossed 1800 parts per billion. And nitrous oxide, yes, it's hovering around 320 parts per billion. So these three are very important greenhouse gases. When you look at the effect, it is the most significant effect of these three important gases. And as far as the sector is concerned, the energy sector is most important thing, because the consumption of the fossil fuels, it releases a lot of greenhouse gases into the atmosphere. Second important sector is the agriculture related sector, agriculture and forestry and other land use sector related sector, because they are responsible for 1/3 of the greenhouse gases emissions into the atmosphere. So these are the two important sectors, and nevertheless other sectors also are equally significant from the perspective of management, from the perspective of mitigation and climate management. Okay. So in today's discussion, we will take very importantly three important gases: the carbon dioxide and methane and nitrous oxide. And when you look at the carbon dioxide concentration, the exact instrumental measurement of carbon dioxide, atmospheric carbon dioxide concentration started in the year 1958 in Hawaii Island, Mauna Loa in 1958. Since then, it has been systematically measured, the atmospheric concentration, and we can see that the increase is much faster. I mean 2 parts per million per year. It's an annual increase is so much, 2 parts per million. It's all because of the population pressure. It's all because of the population pressure and related activities of human beings that is causing the changing carbon dioxide concentration in the atmosphere. And when you look at the carbon dioxide concentration in the complete system, in the climate system, the major part has been stored in the ocean body. Nevertheless, the atmosphere is also holding around 800 gigatons of carbon in the atmosphere. It is there, and that is causing the increase in temperature, because that's basically when you look at the carbon dioxide, or for that matter any greenhouse gases, it is having a very important effect. It's basically opaqueness of the atmosphere to the IR radiations. That is basically, that's called a greenhouse effect. So the main important source of greenhouse gases, particularly the carbon dioxide in the atmosphere, is the energy consumption, or in other words the combustion activity, and also the cement production and land use changes, all responsible for increasing carbon dioxide concentration in the atmosphere. These are the basic sources responsible for increasing the carbon dioxide concentration in the atmosphere. See, and as far as the infrared opaqueness, the carbon dioxide is having ability to absorb the long wave radiation at different wavelengths at 2.7, 4.3 micrometer and 15 micrometer. This carbon dioxide is having an ability to absorb the long wave radiation, infrared radiation, because and that is the most important impact of carbon dioxide in the atmosphere. And next important gas is the methane. Greenhouse gas is the methane, and the concentration is remarkably increased since the Industrial Revolution. It has increased almost from 750 parts per billion to 1800 parts per billion, so much increase. And why? We can see from this particular data itself that how human beings, how the land use changes are responsible for the increasing methane concentration. And basically, if you look at it, the main source of methane in the atmosphere is the agricultural activity. When I say agricultural activity, it can be the lowland paddy cultivation and the ruminant activity or the livestock activities, because animal husbandry also, particularly the ruminants, they are also responsible for releasing most of the methane into the atmosphere. And other thing is waste management strategies, poor waste management strategies like landfills also responsible for releasing methane. So that is the reason why we need to go for a pragmatic and a foolproof waste management strategy, so that the methane from the waste that can be reduced. That, in other words, it can be used also. It can be if you have a strategy, adaptation strategy, if you have a strategy of energy recovery, then it will be highly good. So appreciable. So the main important point here is that the lowland paddy cultivation or animal husbandry activity, the ruminant activity, are responsible for releasing more of methane in the atmosphere. And as far as the absorption band is concerned, methane absorbs at 7.7 micrometer long wave radiation. And nevertheless, if the residence time for this particular methane is very less in the atmosphere, it's around between 9 to 15 years in the residence time in the atmosphere. And very interesting point here is that this, the methane in the atmosphere, it reacts with the hydroxyl group. When it reacts with the hydroxyl group, what happens? You will be finding, because CH4 plus hydroxyl group, so you will be, what kind of product will be released? The ozone will be released, the carbon dioxide will be there, and this also carbon dioxide is again a greenhouse gas, but nevertheless the methane, the global warming potential of methane is 21 times more powerful than carbon dioxide. So the methane, when it combines with the hydroxyl, it releases water vapor, it releases carbon dioxide and ozone. So in a kind of thing, if you see, the very important point is that the duration, that is the residence time in an atmosphere as far as methane is concerned, is very less. So a lot of measures can be taken to mitigate the methane emissions. Okay. One very important point here is that a lot of methane has been stored below the permafrost region. If there is an increase in temperature still further, if you see, because of the increase in temperature, the permafrost can melt, and that can release more of methane into the atmosphere. It is more dangerous. It can really end up in a positive feedback. So measures has to be taken at right time. And the last greenhouse gas is nitrous oxide. For today's discussion, the concentration of nitrous oxide has not been increased so much, but nevertheless from 275 parts per billion to 320 parts per billion. The main important source for nitrous oxide in the atmosphere is again the agricultural activity, because we are using a lot of synthetic fertilizers, whether it's a urea, any kind of inorganic fertilizer, we are using it, and that is causing, because of the processes, biologically mediated process like nitrification and denitrification, that ends up in nitrous oxide in the atmosphere. And also the other activities like forest clearing and land use changes, combustion. These are also other reasons for increasing nitrous oxide concentration in the atmosphere. And it gets degraded only in the stratospheric region through a photolysis process. And as far as the absorption band is concerned, it absorbs at 7.8 micrometer and 8.6 micrometer. So this is all about the greenhouse gases. To sum up, today I've tried to introduce to the topic of climate change. I've tried to explain from the basic understanding of, from the perspective of weather, climate, and what exactly the climate system constitutes, and the kind of interactions in the climate system that we have seen, and how when you look at the natural causes and the anthropogenic causes, how important, how prominent the human action is in causing climate change, that we have seen through the changing the atmospheric concentration of greenhouse gases, particularly the carbon dioxide, methane and nitrous oxide. In the coming sessions, we will be discussing further on different topics of climate change. Thank you.